Hi, this is Mrs. Downey with East Central High School. I'm going to do a review for our Semester 1 study guide for Algebra 2. Our first problem starts with identify a pattern and find the next number in the pattern. So we've got -6, -2, 2, and 6. So if we were to put these on a number line from -6, so if we were to look at how are these moving on this number line, we're going from -6 to -2. We're moving 1, 2, 3, 4 units. So we added 4 units from -6 to -2. Let's look at the next one. We're moving 1, 2, 3, 4 units again from -2 to 2. We've also added 4 units. And then from 1, 2, 3, 4 to 6, we're also adding 4 units. So for all the patterns, each time we're taking the previous number and we're adding 4. So if we want to go to the next number in the pattern, well, our last number was 6, we're going to add 4 to that, and we're going to get 10. So our pattern is to add 4 each time, and our next number in the sequence would be 10. It says insert less than, greater than, or equal to make the sentence true. So we have a -8 times a negative sign. That negative times a negative equals a positive, so it becomes +8, and they want our sign to go here, and 7. So what can we say about 8 and 7? We can say that 8 is greater than 7. So we need the greater than symbol to make the sentence true. Number 3 says which algebraic expression models the given word phrase? 4 times the sum of A and B. So we want to break this down into workable parts. We have 4 times the sum of A and B. So 4 times, so we're going to multiply something times 4. What are we multiplying by 4? The sum of A and B. The sum of A and B. So that is our answer. 4 times the sum of A and B. Solve the equation. Well, we want to start by realizing we just have one variable here, that's y. So we want to isolate our y on one side of the equal sign and put everything else on the opposite side of the equal sign. So let's start by combining all of the y terms on the right. So I'm going to subtract 6y, and what I do to one side, I must do to the other. And that makes it go away, and I'm left with a positive 3y. All right, and this goes to 0. Now I want to get rid of this -8, so I'm going to add 8. And I must do it to the other side. So that goes to 0, and I'm left with a -9. So carrying down our equal sign, I have -9 equals 3y. I still need to isolate my y, so I need to get rid of the 3, do the opposite. So if I'm multiplying 3 times y, to get rid of the 3, I must divide. So divide to both sides, and I end up with y equals, and 3 goes into -9, -3 times. So y equals -3 is my solution. Number 5 says, what inequality represents the sentence? So 12 fewer than a number is at least 3. So breaking it up into pieces that we can work with mathematically, well, we can figure out that 12 fewer than a number is just n for the number minus 12, right? That's 12 fewer than a number. Is at least, that's going to be some kind of inequality symbol, it's at least what? 3. So we're missing a symbol here. It says is at least. So it means whatever this quantity is here, it could be 3. At the very least, it's 3. Okay, it didn't say it's less than. It said at the very least, it's 3. That means the least number it could be. So it means it could be anything greater than 3, but at the very least, the very smallest it can be is 3. But it can be anything bigger. So we're going to say that n minus 12 is greater than or equal to 3. And that's our equation. Number 6 says solve the inequality, graph the solution set. So I have 9 plus 3k is greater than or equal to 0. All we're doing here is just solving for the k. So we want to get rid of everything other than the k. I always say start from the furthest thing away from k, and that would be our 9. So let's get rid of the 9. Subtract 9 from each side. That goes away, and we're left with 3k is greater than or equal to negative 9. Now we've got to separate our 3 and our k, so divide by 3. And we don't have to flip the sign because we divided by a positive number. If you multiply or divide each side by a negative number, you must flip the inequality sign. But since ours was dividing by a positive number, we don't have to. We're left with k is greater than or equal to, and again, 3 goes into negative 9, negative 3 times. So solving the inequality, we get k is greater than or equal to negative 3, but then it said graph the solution set. So we're talking about a number line. I always like to put the number that we're speaking about right in the center, and I like to put 2 more for reference. So we've got a negative 2 here and a negative 4 over there. So we said it could be equal to negative 3, so we're going to fill the dot in, and it's greater than or equal to. So we're going to shade to the right and shade our arrow, showing that it goes on forever and ever. And that concludes the first 6 problems of our study guide. Keep watching for the next set. For number 7, it says solve the absolute value equation, graph the solution. So for number 7, we have 4 times the absolute value of 3x minus 2 minus 6 equal negative 2. The first thing we want to get rid of is this negative 6. We're trying to isolate x here. So we want to start with the furthest thing on this side of the equal sign from the x. So we're going to add 6 to each side. When we do that, this goes away, and I have a 4 here. It leaves me with 4 times the absolute value of 3x minus 2 equal 4. The next thing I'm going to do is divide each side by 4. And it cancels out. So we end up with the absolute value of 3x minus 2 equal 1. All right, the next thing we have to do is solve this to remove our absolute value symbols. We have to solve this as a positive 1 and a negative 1. So we end up with the absolute value of 3x minus 2 equal 1. So we're going to solve it both ways. 3x minus 2 equal a positive 1, and 3x minus 2 equal a negative 1. So to solve this, add 2 to each side, and we get a 3x equal 3, so x is equal to 1. And on this side, we're going to add 2 to each side, and we get 3x equals 1. So dividing each side by 3, we get that x equals 1/3. So our answer becomes x equal 1 and x equal 1/3. this is our answer. To graph it, I'm going to put a number line here, 0, 1, -1, and 2. So we have it at x equals 1, and just about right there at 1/3. Okay? And this is our answer. Write the ordered pairs for the relation. Okay, for the first one, we want to get the x and y coordinates of each point on here. I'll start with the left and move to the right. So the first one, our x value is -4.5, and our y value is 5. Okay, for this point here, it looks like our x value is -1, and our y value is a +1.5. For this point here, we say x is 0 and y is -1.5. For this point here, we've got a 1 and a 1.5. And for our last point up here, we've got 4.5 for x and 5 for y. And those are our points. The domain and the range, the domain is equal to all of our x values. So when you look, and it's a set of values. So in our domain, we want to see where each one of these are hitting the x-axis. All right, so the first one, we've got -4.5. The next one is at -2. After that, it's at 0, at 2, and 4.5. Okay, now for our range, we're going to reverse the process, but with the y. Okay, so we're going to go here, 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 and here. So we've got it -2, 1.5, and 3.5. And that's our answer. Number 10 states vertical line test, and it says use the vertical line test to determine which graph represents a function. So what you want to do is look at the graph, draw a vertical line through the graph, and if the vertical line intersects the graph in more than one point, then it fails the vertical line test. If it intersects in only one point, then it passes the vertical line test. So pass means it is a function, fail means it's not a function. So here are two examples. Notice the blue line here, and there's 3 vertical lines running through it. It means if you can draw a vertical line anywhere on the graph, here any vertical line we draw on this graph will only intersect at one point. So this is a pass. On the next one, we could draw a line right here and it would pass. But look what happens if we draw over here. Right here, it's intersecting in 1, 2, 3 points, so that's a fail. So this would be created from a function on the left, and the one on the right is not created from a function. It's a fail. For each function, what is the output of the given input? So they give us that f of x is equal to x plus 6. Find f of -1. All we're going to do is replace all the x's with -1 and simplify. And this is our answer. F of -1 equals 4. Determine whether y varies directly with x. Again, right there, that's a direct variation. Y equals kx, in which k is our constant of variation. Okay? So the first thing I'm going to do is see if we can make our equation 7y equals 5x look like the y equals kx. So let's see what we can do. 7y equals 5x. Well, we want to get it to look like that. So let's divide each side by 7. And we end up with y equals 5/7 x. So that does match. So it is a constant of variation, or it is a direct variation. And our constant of variation is this k value, 5/7. The last one I'm going to work is what is the slope of the line that passes through the given points. Well, we know that the slope formula is y2 minus y1 over x2 minus x1. Well, this is x1, y1, and that's x2, y2. So we're going to go -9, slope equals -9 minus -9 over 2 minus 3. It's a minus. So our minus and minus up here goes to plus. -9 plus 9 goes to 0. And 2 minus 3 is -1. Well, anything, any 0 over any number is just 0. So our slope is equal to 0. And we'll stop here. Hi, this is Miss Downey, and this is part 3 of my video series on the Semester 1 study guide. The next problem we're going to look at is write the equation in slope-intercept form. What are the slope and the y-intercept? Well, slope-intercept form goes y equals mx plus b, where m is our slope and b is our y-intercept. So we want to work this equation with that formula. So let's start by writing the equation, -6x minus 11y equal 10. And we want to isolate this y on the left side, moving everything else over on the right side of the equal sign. So we're going to start by getting rid of the 6x. So add 6x to each side. And when we do that, this goes to 0. Carry down our -11y equals, and putting them in order, 6x plus 10. The next thing I'm going to do is isolate the y. So I'm going to divide by -11. That means everything gets divided by -11. Okay. The trick of algebra is to keep everything in balance. All right. So what you do to one, you must do to all. So this cancels out, and I'm left with y equals, and cleaning these up, -6/11 x minus 10/11. All right, and that is our equation. So that's the first part. They said write the equation in slope-intercept form. Part 2 said what is the slope and the y-intercept. So our slope, which is -6/11, and our y-intercept, which I'm going to call b, is -10/11. And there's both parts of our question. The next question, number 15, says what is the graph of the equation? And they give us something in standard form. We know it's standard form because standard form is ax plus by equal c. So the great thing about standard form is you can plug a 0 in for x and y and get the intercept. And that makes our equation's very easy to graph. Okay, so here's my y, here's my x. Go. All right, so the first thing I'm going to do is plug in a 0 for my y and solve for x and get my x-intercept. So when I do that for a 0, it just gets rid of that, and I'm left with negative 3x equal negative 3. So now I'm going to divide each side by negative 3. That cancels out, and I'm left with x equal, the signs cancel out, and the 3. 3 divided by 3 is 1, so I get x equals 1. So when y is 0, x equals 1. What this is a coordinate pair, right? So when you graph that, 1 and 0, it takes you right there. So there's our first portion. Now let's reverse the process and turn x to 0. When we turn x to 0 here, use this color. When I turn x to 0, the negative 3 times 0 just goes to 0. And I'm left with my answer of y equals negative 3. See how simple that is? And that's why we love standard form. So there's my x and y intercept at 1, 0, and 0, negative 3. All right, because that was our x and our y's. And now all you do is connect the two by putting a line between them. Let me see if I can fix this. There. That goes about right. There we go. And that's the graph, of course, with arrows, because that line goes on forever and ever. And that's the graph of our equation. Number 16 says, what is an equation of the line in point-slope form that passes through the given point and has the given slope? So the first thing I'm going to do is think about what is the point-slope form. That is the one that says y minus y sub 1 equals m times x minus x sub 1. And I'm going to write this a little bigger. They tell us that our point is 8, 6. So there's our x1, y1 right there. And they tell us that our slope is equal to 1/4. Okay? So let's write the equation. So we're going to have y minus y1, which is 6, equals m, which is 1/4, times x minus x sub 1, which is 8. Okay, at this point, you would go through and clean up any signs like plus, minus, minus, plus. We don't have any of those. Ours is straightforward. So that is our answer. Y minus 6 equals 1/4 times x minus 8. And you leave it in this form because it matches our formula. Okay, you don't distribute the 1/4, you keep it just as it is. That's our answer. 17 says, if a function called f of x is shifted to the left 2 units, so we're going to shift it to the left by 2 units, what function represents this transformation? So we've learned when we move things horizontally across the x-axis, this way or that way. If we move it to the right, we do a minus 2. If we were moving it to the left, we would do a plus 2. It's sort of backwards when you shift it across the horizontal axis, across our x. So we know it says we're moving to the left by 2 units, so we're going to add 2. So this becomes f of x plus 2. And that's our answer. I'm going to start this on the next video, so we're going to stop here. And thank you for participating. Study hard. Hi, this is Mrs. Downey, and we're continuing our Algebra 2 Semester 1 study guide. I'm starting with number 18. It says, what is the graph of the absolute value equation? Well, we're starting with y equals -2 times the absolute value of x plus 5. Well, you have to think, what is the parent function of this equation? Well, our parent function is going to be y equals the absolute value of x. And it's going to look like this. It's going to be a V shape, and it's going to run through the origin, and it's going to divide our first and second quadrants into two pieces. Okay, so that's the parent function, and this is where we start. Now let's start tearing our problem apart and seeing what have they added to it for our transformations. So the first thing I want to look at is this. We've got a negative sign. So the negative sign in front of a coefficient of the absolute value. The negative sign here means we're going to flip over the x-axis. And the 2 here, that's going to be either a compression or it's going to be a stretch. If this number in front of our absolute value of x is between 0 and 1, it's a compression, and that means it would flatten out our sign. But it's not between 0 and 1, it's greater than 1, it's a 2. So that means anything greater than 1 is a stretch. So it's going to take this parent function and stretch it out so it becomes skinnier. So it's going to look something like this. So we move the old one away. So the parent function was here. The stretch is going to look a little skinnier. That's not exact, but remember, you're picking these from multiple choice. So you're looking for one that's skinnier. Now let's talk about, what did that negative sign do? The negative sign flipped it over the x-axis. So let me group this together. And let me see if I can, well, I'm going to trick it a little here. So we flipped it over the x-axis now. So it's going upside down. And now we've added the stretch, the flip, and now our last part here is the add a 5. Add 5 to it. So what that does, it's going to move it up or down depending on your sign. We're adding, so that means we're moving up 5 units. So 1, 2, 3, 4, 5, and we're going to group it and move it up. Come on. 5 units. There we go. So that's what it's going to look like, of course, with arrows on each end. And there's your X and Y. All right, so that is what our final problem would look like. And again, the original was there. And our transformation is the one that's flipped. Okay. The graph of each, what is the graph of each inequality? So now they're giving us one problem for number 19. X minus 3y is less than -5. Well, I would put this into slope-intercept form, and let's graph off of that. So the first thing I'm going to do, slope-intercept form, is y equals mx plus b. It's easy to graph that way, and we can follow our shading rules. So let's try to get it in that form now. So I'm going to subtract x from each side and get rid of the x here. And we're left with negative 3y is less than negative x minus 5. Now the next thing I'm going to do is divide everything by negative 3. And because I'm dividing by a negative, I have to flip this sign the opposite direction. All right, this cancels out, and I'm left with y. Signs cancel, and this becomes a positive x over 3, which is the same as 1/3 x, and these signs cancel out to positive, plus 5/3, which is 1 2/3. So this is easy to graph. So we're going to start by graphing our y-intercept of 1 2/3. So here's 1, 2. So 1 2/3 is going to be about right there. Okay, and then we've got a slope, rise 1 and run 3. That's what 1/3 means. Rise 1, run 3. So from this point, we're going to rise 1. So from 2/3 to the next 2/3, there's rising 1 right there. And we're going to run 3. 1, 2, 3. So it's going to take us about right there. Okay, and now we need to look at our sign. It's just greater than, so we know it's a dashed line. So let me grab my line and finagle it. And it's going to look something like this. Okay, and it's going to be a dashed line with an arrow on each end, and it's greater than, so it's going to be shaded above. So when we shade, we're shading above the dashed line. So this is what our graph is going to look like. Hi, this is Miss Downey, and we're continuing our Algebra 2 Semester 1 study guide. I'm continuing with number 20, solve the system by graphing. They give us two equations, and to graph, the easiest way to graph is just to put things in slope-intercept form. And let's do that with both these equations and graph them. So I'm going to start with the first equation, negative 4x minus y equal 1. I'm solving for y. To put it in slope-intercept form, that means I'm going to add 4x to each side. Okay, and then that leaves me with negative y equals 4x plus 1. Now, let's get rid of the negative sign. Divide everything by a negative 1, and it flips every single sign. And then this changes to minus 1. So we get y equals negative 4x minus 1. And that's the first one we're going to graph. All right, so there's our first equation transformed. Now let's transform our second equation. Use a different color. And now we have x minus y equal negative 4. So again, subtract x from each side. Okay, and divide everything by a negative 1, and it's going to flip every sign. And let's put it in the proper form, y equals x plus 4. And so here are our two equations now that we're going to graph. So in a slope-intercept form, we've got our x and y axis. And the first thing I'm going to do is look for my y-intercept. So on my first equation, I've got a y-intercept of -1. So I'm going to come down to -1. I'm going to put a little dot there. That's where he's crossing the y-axis. And now we're going to count our slope out. Well, it's a -4. Also just a -4 over 1. So that means we're going to go from this y-intercept, we're going to go down 4 and to the right 1. So 1, 2, 3, 4, and to the right 1. And that's really off scale, but it's good enough for our demo. Right there. Okay, so this is going to be a line that looks something like this. Okay, with our arrows. Whoops. With arrows on each end. Okay, and then for our next equation, we're going to graph the y equals x plus 4. Well, we still have a slope of 1, and to turn it into a fraction, 1 over 1. So that means we have a y-intercept of 4 for our second equation. So 1, 2, 3, 4 up here. Y-intercept of 4, and we're going to rise 1 and run 1 for our slope. So rise 1, run 1 for our slope, and we're right here. Now let's create this line. And it's going to do something like that. Okay, so where are they? Oops, didn't mean to do that. Where are they intersecting? So my graph was a little off, but if you really look at it, if everything was correct, it looks like it's at about -1 on the x-axis and 3 on the y. And that is our answer. Okay, so moving on, our next problem is to solve the system by substitution. So when we solve by substitution, we are going to take one of the equations and solve for one variable. So pick the one that's easiest to work with. It's pretty apparent that they're both pretty easy, but this one's a little easier because there are no coefficients other than 1 for our x and y. Makes it just a little easier than the other one. So we'll pick this one, and we're going to solve for one variable. So it doesn't matter which one. In the end, it's all going to work out. Because my x is positive, I'm just going to choose to solve for x. So I'm going to have x minus y equal -2. So I'm going to keep my x and get rid of my y. So what you get, that cancels out. X equals y minus 2. I'm going to write this up here. So there's the value that I'm going to substitute. So every time in the other equation that I see an x, I'm going to substitute what x is equal to, y minus 2. So that's that equation. Now let's work with this equation. This is what we're going to substitute into. So start by writing the equation x minus 2y equal -6. And everywhere we see an x, we're going to replace it with our y minus 2. So let's do that. So it's going to be y minus 2 minus 2y equal -6. And now just clean it up. So combine your like terms of y and negative 2y, and we're going to get a negative y. And then add 2 to each side to get rid of that. And then we're going to have negative 6 plus 2 is negative 4. Now we have negative y equals negative 4, so divide each side by a negative 1, and it flips both the signs around. So we get y equals a positive 4. So we have half of our equation, or our solution, excuse me. We have a 4. Now what we're going to do is plug this back into any of our equations here, the ones that we started with or the one that we solved for the one variable. And actually, because we've got a y and we're looking for our x, this one is perfect for us. So let's plug our y back into that equation and we'll get our x. So x equals y minus 2. And we said that y is equal to 4. So we're going to replace y with 4. And when we get that, we get x equals 2. So now we have both of our values for our point of intersection. And truly, what this represents is where do these two lines intersect each other. That's the solution. So they intersect at 2, 4. And that's how to solve this by using substitution. Thanks for watching this segment, and I'm going to stop here and move on to 22 in the next section.